The Physics of Swimming by Connor Bird. Swimming may seem like a simple human activity, but it's actually a complex interaction of forces, motion, and momentum. In this video, I'll break down the physics behind three key parts of swimming: how swimmers can hold another person above water, the physics of diving, and the physics behind the front stroke. One of the most impressive feats in swimming is lifting another swimmer above your head while staying underwater. But how can they do it? The first major concept is buoyant force, described by Archimedes' principle. This equation shows that the upward buoyant force depends on the density of water, gravity, and the volume of water displaced. Because the human body is so close to the density of water, buoyancy significantly reduces a swimmer's apparent weight. Next, Newton's third law explains how swimmers generate lift. When a swimmer sculls their hands or kicks downward, they exert a force on the water. The water pushes back upward with an equal and opposite force, helping support both swimmers. This motion involves forces and inertia. The swimmer must continuously apply force to overcome inertia and keep the lifted swimmer from sinking. Finally, momentum plays a role. Rapid sculling increases the change in momentum of the water. By pushing the water downward quickly, swimmers generate a large upward force. Diving. When a swimmer dives, their motion becomes an example of two-dimensional kinematics. Once the swimmer leaves the board, they follow a projectile motion. Horizontal velocity remains nearly constant, while vertical motion accelerates due to gravity. As the swimmer enters the water, momentum and impulse become critical. The force experienced by the diver depends on how quickly their momentum changes. A streamlined hands-first entry increases the time over which momentum decreases, reducing the force and preventing injury. Drag force also slows the swimmer, which depends on the velocity and surface area. Front stroke. The front stroke is a balance between propulsion and resistance. When swimmers pull water backwards with their arms, they push water in the opposite direction. According to Newton's third law, the water pushes them forward. At the same time, swimmers experience drag force. This equation shows that drag increases with the square of velocity, which is why even small increases in speed require much more force. This motion also involves kinematics, since swimmers try to maximize forward displacement per stroke and inertia, because once moving, a streamlined swimmer resists changes in motion. Efficient swimmers reduce drag by minimizing surface area and maintaining horizontal body position. Swimming is a powerful real-world example of physics in action. Buoyancy, forces, momentum, inertia, and two-dimensional motion all work together every time a swimmer moves through the water. Understanding these principles not only explains how swimming works, but why technique matters so much. Thank you for watching.